In this tutorial, we will be discussing how to determine the KSP. There are two different types of KSP problems that are possible. One is calculating the KSP itself, given the concentrations and the molarity of the products. That's the one we're going to be focusing on this tutorial. The other type is when you're given the KSP and you're trying to calculate either the concentrations, the molarity of the products, predicting the solubility of the concentrations and molarities required to have a precipitation, or the common ion effect on precipitation reactions when given the KSP. So the first type is when you solve for the KSP. The second type is when you're given the KSP. So we're going to do a couple examples of these. Let's say we have lead bromide that's being dissolved in water. Alright, so that breaks down. Here's our lead bromide into lead, and then because of this 2 here, we have 2 bromine. Now remember that the KSP, the coefficients get raised like that. So initially, we don't have any of the lead or bromine in the solution. Then we add it to water, and we have 1.05 times 10 to the negative 2. And then because of this 2 out here, it's going to be 2 times 1.05 times 10 to the negative 2, because it's going to produce, for every lead that's produced, we're going to have 2 bromines that are produced. And then from here, at equilibrium, the concentrations will be 1.05 times 10 to the negative 2, and then 2 times this, which is 0.021. From here, we're going to plug it into the KSP equation that we've already derived. The lead is 1.05 times 10 to the negative 2. And then the bromine is 0.021. Now because of this coefficient of 2, we're going to square that. That comes out to be a total of 4.63 times 10 to the negative 6. Let's do another one. Now let's look at lead iodide. Once again, they give us the equilibrium concentration. So we're going to set up the ICE table because it's an equilibrium product. We also want to know what the equation is for KSP. Well, that's going to be the concentration of the lead multiplied by the concentration of the iodine. And because of this 2 out front, we're going to square that. Alright, so let's go ahead and set up our table. Initially, we don't have anything. And then once we dissolve it in water, our lead concentration is 0.00130. Our iodine concentration, because of the 2, is 2 times 0.00130. So at equilibrium, 130, and then the iodine this time is 0.00260. Now we can determine the KSP. The lead at equilibrium is 0.00130. It does not have a coefficient, so I don't have to worry about squaring it or anything like that. Then iodine is 0.00260. It does have a coefficient of 2, so I'm going to square it. If it was 3, I would cube it, so on and so forth. Multiply that all out, and I get 8.79 times 10 to the 9th. And that's how you solve for KSP.